All right, in this video, we're going to be going over some quadrilateral proofs that utilize our knowledge of triangle congruence and furthermore, our knowledge of CPCTC. So just a review for us, these are the 5 triangle congruence theorems. And remember, all 5 of these would be reasons in your proof. And they would justify a statement. Your statement would look something of the sort: triangle ABC, or whatever 3 letters they are, is congruent to triangle DEF. And again, these letters are just placeholders, but the main thing that you should understand is that each of these 5 things go as reasons, and the statements that go along with them are just saying that 2 triangles are congruent. Now remember that once we have that 2 triangles are congruent, we're allowed to use CPCTC to say that the other pieces, the other corresponding parts, are congruent. Now, for example, let's say that we are able to use side, side, side congruence here. We're missing some info about the angles in this diagram, right? So if we know that the 2 triangles are congruent using side, 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 we know that their corresponding angles are the same as well, right? So this angle that's in between the side with the singular and the double tick mark, right? We know that those 2 angles are congruent. We know that the angle in between these sides with the 2 tick marks and the 3 tick marks are congruent. And last but not least, this last angle here between the 1 and the 3 tick mark would also be congruent, right? And then let's say, on the other hand, let's say that we used side angle side to say that the 2 triangles were congruent, right? CPCTC allows us to make info about the other missing parts. For example, if we know that these 2 triangles are congruent using side angle side, we're able to use CPCTC to say, hey, this third pair of corresponding sides must be congruent, and the same thing goes for the angles as well, right? So the angle in between the 3 and the 2 tick marks would be congruent, and then the angle in between the 1 and the 3 tick marks would be congruent, right? So we can do the same with the other triangle congruence theorems as well, just to show you how CPCTC works. But just know that once you know triangles are congruent, you're able to use CPCTC as a reason in your proof to justify any corresponding part being congruent to one another. A lot of people confuse HL though. For HL, you do need a right triangle, but just because you have a right triangle does not mean you're going to use HL. In order to use HL, you need to have that the hypotenuses of your right triangles are congruent, and then one of the legs must be congruent as well. So let's just say, for example, we knew here that triangle ABC was congruent to triangle DEF. We can use the letter trick to help us out here, right? If our triangles are not drawn in the same orientation, we know that we can kind of write the letters right on top of each other. This kind of helps us see it. We can see that angles A and D are corresponding, so they must be congruent according to CPCTC. B and E correspond with one another, so they must be congruent, and then C and F must also be congruent because they are corresponding parts. Now we can use this for sides as well, right? A, B, and D, E go together. They're corresponding parts, so they must be congruent. Then we have BC and EF would be congruent because of CPCTC. And then lastly, we have AC, which are the first and the third, and DF. Those segments would be congruent again because of CPCTC. So if we are given triangle congruence, or we can get there somehow, we're going to be using CPCTC to help us make some conclusions with our parallelogram stuff and our the rest of our quadrilateral families. So just recall this quadrilateral checklist, and know that whatever shape you're trying to prove, we know that parallelogram comes first. Quadrilateral really does come first, but it's a very basic concept, so the Regents doesn't really care much about the quadrilateral portion. But you got to start from parallelogram, and then you are choosing a route to go. Now, this isn't written on your checklist, but I want you guys making a note of it right now. So if you can satisfy 1 from rectangle and rhombus, then you have a square. So make sure you guys go ahead and add that in. And make sure you're also familiar with the symbol for parallelogram. You can also, instead of writing the whole word out, you can go like this, a P with a little box looking, it almost looks like a parallelogram around it. All right, so in these proofs, we're going to do 3 of them together today. You want to make sure you are mapping this proof out, because that's what we should do for every proof. As they get longer, they're only going to get more complex to follow. So you want to make sure you kind of have a planning page just so that you're not starting in the dark. So we always start by reading our given. It says given triangle RSU is congruent to triangle TUS. It wants us to prove that we have a parallelogram. So on my checklist, I know I'm only dealing with this section. I don't have to go any further than a parallelogram. So to be honest, I can really cross this out right now for this example. And the biggest thing that's standing out to me is that they give us triangle congruence. And when they do that, I feel like we're going to use CPCTC right away. And you guys should be writing this down as well. I'm kind of modeling, this is like in your little planning area, how we can go about this proof. So I want to use CPCTC, and I know I need to get to one of these 5 methods. So usually, if I can use CPCTC, I'll usually try to go this route of method number 2. So to prove parallelogram, right, I'm going to use method 2. And I'll even write that out because we're not always going to have the checklist next to us. So for parallelogram, I want to use that both pairs of opposite sides are congruent. I know that I can get there with CPCTC. And to be honest, if we can attack these 2 things on our planning page, then we're going to be done. This isn't going to be that long of a proof because we don't really have to go too crazy down the family tree here. So let's go ahead and actually do this proof together. So make sure we're writing out our statement and our reason chart. And let's make sure we're writing out our given. So triangle RSU is congruent to triangle TUS, and that is our given info. Now I'm gonna, just for time's sake, I'm gonna use the letter trick. So I'm writing out triangle RSU and triangle TUS just so that I can see the corresponding parts to see which one will be able to help me. So I know that if I can get this side here congruent to this one, right? And obviously the other pair of sides congruent, then I know I'll be able to use method 2 to prove parallelogram. So let's see if we can actually do that. So RS and TU actually do go together. They are corresponding pieces of those triangles. So we can use CPCTC here. So I know RS is congruent to UT. And again, my reason here is we already know that the triangles are congruent. So when we know that, we can use CPCTC to say that the corresponding sides or angles are congruent. Now, I can make a bunch of other conclusions here, but we got to figure out, pick and choose which ones are going to help us. Now, the next piece we needed, right, was RU and ST. So let's just double check that. So RU is first and third, and then S and T are also first and third, so they are corresponding pieces. So I know using CPCTC again that they would be congruent to one another. So RU is congruent to ST. Reason again is CPCTC. Now you could have combined this into one, like you could have like taken away the 3 and just written CPCTC once, but that's totally up to you. It's preference. Whether you did it or not. Let's keep this as step 3 though, just for the sake of organizational purposes. So now let's double check. If I go back to my checklist, I needed that both pairs of opposite sides were congruent, and we have that. So now I'm able to say confidently that RSTU is a parallelogram, right? And our reasoning should mimic the words of the checklist. So we are using the fact that both pairs of opposite sides are congruent. Done. All right, so let's get into this next question. The next question is going to be a little bit more involved, but we're going to do the same thing. We're going to plan it out first, and then we will start to attack it. So we have triangles AEB, AED, DEC, and BEC are all congruent. Wow, that's a lot of triangles. It's 4 different triangles. So if we look, it's these 4 smaller triangles here that are created by the diagonals of this figure. And then we also have that angles DAB, ABC, BCD, and CDA are 90 degrees. So I'm going to go ahead and label that real quick just so I have an idea of what's going on here. And we want to prove a square. So this is the most involved proof here because we're going all the way down the family tree. So I know that we need to attack parallelogram first. And then we have to choose a route that we want to go. We're either going the rectangle route first and then the rhombus route, or rhombus then rectangle. But what's standing out to me right now is that I see right angles. So when I see right angles, the rectangle is just shouting out to me because a rhombus doesn't have to have right angles, right? But a rectangle does. A rectangle says that all the angles are 90 degrees. So I feel like let's start writing this out. So again, we're given triangle congruence, so I feel like we're going to be able to use CPCTC right away to help us get a parallelogram. It's kind of what we did in the last proof, right? So to get a parallelogram, I'm going to use method 2. Again, I'm going to try to. And again, if we plan this out and it doesn't work, like we can always go back and readjust, which might happen. But let's see. I want to try to use that both pairs of opposite sides are congruent, because I feel like that's what we can, it's like an easier route to go when you have CPCTC. And then right after that, I'm going to go the rectangle route. So I'm going to go parallelogram first, then I'm going to go rectangle. And the method I'm going to try to use for rectangles is that the angles are 90 degrees, because we have that, right? And we actually didn't even need all the angles to be 90. If we had a parallelogram, then one right angle would have been sufficient, but we do actually have all 4. So all angles are 90 degrees is what we'll use for rectangle. And then once we have rectangle, we can use any of the 3 rhombus properties. Now, what's standing out to me here is that all 4 of these small triangles are congruent. So which means that all of the bases, all of the bottoms of them are going to be congruent. So I feel like we're going to be able to use this fact. So for rhombus, we can say maybe go the route of all sides being congruent. Again, we might have to change this up, but hopefully we can go this route. So let's actually get into it. Let's write our statement and reason chart. And this given is very long, but we're going to write it all out. We're not going to be lazy here. If you're lazy, you're risking losing points. So AEB is congruent to triangle AED, is congruent to triangle DEC, is congruent to triangle BEC, and we have angle DAB, angle ABC, angle BCD, and angle CDA all equal 90 degrees, and we have that as our given. Okay, now again, our first route was to try to use CPCTC to help us get somewhere, but you know what, before we do that, I'm going to just cover all of our tracks here. And they're giving us that all 4 of those angles are 90 degrees, but it doesn't necessarily say that they're congruent. So just to cover our tracks and make sure we're all good, I'm going to go ahead and actually state that. So angle DAB is congruent to angle ABC, is congruent to triangle BCD is congruent to angle CDA. And our reason there is all right angles are congruent, just to cover our tracks there. Now let's try to use our CPCTC. So if we use our letter trick and we write all of these out, AEB, AED, DEC, and BEC, we can see that, like, and you can draw them out too, right? But the first and the third, right? So AB, side AB, which is here, is going to be congruent to side AD, which is here. It is going to be congruent to side AC. Oh, sorry, that's DC. It's going to be congruent to side DC, which is there, which is also going to be congruent to BC. And again, it's because all of those 4 sides are corresponding parts of triangles that we know are congruent. So, and if you wanted to actually draw them out, you'd be able to see that it's the bottom part of each triangle. But in our statement, let's just go ahead and say that all 4 sides, so AD is congruent to DC, is congruent to BC, is congruent to AB. And again, our reason there is CPCTC. Now we actually have enough to go our parallelogram route. So we have ABCD is a parallelogram, and the reasoning is because both pairs of opposite sides are congruent. And then in our plan, we said we were going to go the rectangle route, and I forgot to relabel this, but we have right angles here. So right away, we don't even need to do anything else. We also know that ABCD is a rectangle. Now, rectangle doesn't have a symbol, so you got to actually write out the whole word. And the reason is, let's use our checklist. So the first thing said it had to be a parallelogram, right? So a parallelogram with, and the condition that we're using is the 4 right angles. So a parallelogram with 4 right angles is a rectangle. Now, again, remember, the checklist says we didn't need to have all four. Like if we just had one of those angles, our reasoning would have been a parallelogram with one right angle is a rectangle. But since we have all four, we might as well just say it. Now, we said that if we can check off one other thing for a rhombus, if we can check off one thing from a rhombus already having a rectangle, we know that we have a square, right? So our next thing, I know that I can check off the fact that all four of these are congruent. So the route that I'm going to go, I'm going to say ABCD is a square. And the reason is because a parallelogram, a rectangle with four congruent sides. And again, I'm literally just using the checklist. We already have a rectangle, and we said we only needed to check off one thing from a rhombus. So the thing we're checking off from a rhombus is the four congruent sides. So a rectangle with four congruent sides is going to be a square. Now, do not get lazy with your reasonings or your statements. You need to make sure that you're actively explaining everything, just so that you don't lose any silly points. Because if you have this whole thing down pat and you lose a point for being lazy, it's very silly. All right, so for this question, it says ABCD is a parallelogram. It says that ED is congruent to FD, which is already labeled for us. And then it says that AE, which is right here, is perpendicular to ED. So where those two lines meet, there's going to be a right angle. And then it says that CF, which is right here, is perpendicular to FD, which is right here. So where those two lines meet, I know we're going to have a right angle as well. In this question, we want to prove that we have a rhombus, right? So again, we know that we need to prove parallelogram. We can kind of X rectangle out, that's out of the picture, and then we know we're going to need to check off one of these, right? Now, this one's a little bit different because it doesn't give us triangle congruence like the other ones. But to me, I'm looking at these right triangles here, and I feel like we're going to be able to prove those to be congruent somehow, and that's going to eventually help us prove that we have a rhombus. So I know in my game plan, and we should be writing this out, I want to somehow prove triangles to be congruent, like triangle 1 and triangle 2, I'm just calling them. I know I want to prove them to be congruent, and then if we can do that, we're going to be able to use CPCTC to help us out. Oh, okay, I was getting tripped up because it already tells us we have a parallelogram, because I was thinking about doing that. We already know that, so actually we don't even need this. The question gives us that, which is kind of amazing. So we literally already have this. We only need one of these three over here. All right, so I feel like if we can use CPCTC to get that this piece is congruent to this piece, then we're gonna have enough to prove the rhombus. So let's get into it right now. So don't forget, we have a statement and a reason chart. And again, sometimes it might not go to plan. We might have to shift our plan, which is okay. So ABCD is a parallelogram. Yes, you have to write all the givens. ED is congruent to FD. AE is perpendicular to ED. And CF is perpendicular to FD. Now, don't forget, I'm going to get this out of the way right now. Do not forget that when you're given something about perpendicular lines, you need to have two statements and reasons automatically. And the first thing that comes with that is naming the right angles. So angle DEA and angle DFC are 90 degrees. Or you can say they're right angles. And the reason is just because all perpendicular lines form right angles. And then what comes right after this, and a lot of people forget this all the time, yes, you stated that they're 90 degrees, but you didn't say that they're congruent. And if you don't state that they're congruent, you're not going to be able to use any congruence theorems. So DFC, and again, the reason here is because all right angles are congruent. Now, this seems obvious. Obviously, if they're both 90 degrees, they're congruent, but you have to just state out all of your logic here just to cover your tracks and make sure you're getting all your points. Now, okay, this is also testing some prior knowledge here. Remember that when we have this X shape that's formed, we have vertical angles in here, and these vertical angles are actually going to help us out. So I didn't see that at first. So we have angle EDA is congruent to angle FDC. And this is such a throwback, but vertical angles are always congruent. Always be on the lookout for that prior knowledge stuff, because it will help you. Because now, guess what? Now we can actually check off our first step of our game plan in proving that triangle. I don't know if I'm going to use it in the right order, so let's see. Triangle AED is congruent to triangle CFD. And the reason here is none other than angle side angle is congruent to angle side angle. Now don't be fooled. Remember, I said just because you have a right angle does not mean you're using HL. You got to kind of mark up your stuff and see what you got. Right after we have triangle congruence, we should be using CPCTC. Now, what is going to help us, again, is what I said, is if we can say that these two parts right here are congruent. So let's do that and see where we land. So AD is congruent to DC. And the reason there is cool people, complete task cards. Just kidding. CPCTC. And then we can go ahead and make sure we label that. Now, the interesting here, I have to actually add to this checklist. So we're done right now. So ABCD is a rhombus. Now, the reasoning here, it's similar to the checklist when it said, oh, for a rectangle, you need 4 right angles, but we said that one of them, having 1 right angle, was sufficient. It's a similar idea here, and I'm going to mark this up in blue so that you guys don't have to mark this up, but we already know we have a parallelogram, right? So we already know that opposite sides are congruent. So if this has 2 tick marks, I know this is going to have 2 tick marks. Same thing for AD and BC, right? So you don't need to, you can go the whole logic of, saying all that, but you can go ahead and just say ABCD is a rhombus, and your reasoning is because a parallelogram with adjacent sides congruent is a rhombus. Now, adjacent just means next to, right? So we had these 2 consecutive sides, or these 2 adjacent sides. We knew that those were congruent. So we can kind of use our logic of parallelogram stuff to know that the other pair is going to be congruent as well. But a parallelogram with adjacent sides congruent is a rhombus. And then we are done. So these proofs might take you a long time. But again, you want to plan them out. And just go slow with it, because you guys know all this stuff and how to make the statements and reasons, but I feel like it's a matter of putting it together. Think about it as writing a story. You're going to have a beginning, a middle, and an end, and you just want to make sure that you are mathematically justifying each of the things that you are saying.